Every time I play Minecraft, I get annoyed by my clutter. My inventory is abysmally unorganized, my storage chests are beyond repair, and I spend more time sifting through my hoard of junk than I do building. What I need is a sorting system. So here's what I'll do. From the beginning of my world, I use a sorting system to put everything I collect into a color-coded storage shed. How I got the resources to build this system so early on is beside the point. Right now, all my oak wood goes to the red chest, all my dirt goes to the orange chest, and all my cobblestone goes to the yellow chest. The rest of the chests are empty right now because I haven't collected any other items to store. What's important is that if I put in some more oak wood, or dirt, or cobblestone, then they'll be sorted into the proper chest, so it'll be nice and organized. In fact, this sorting system is the idea of a function. Functions take each element from one set, which we call the domain, and match them, or as we say map them, with one and only one element from another set called the codomain. My item sorter takes in items from the set of items I've collected and matches them with the designated color. In this case, the set of items I've collected is the domain, and the possible chest colors is the codomain. One other useful term is the range, which is the set of values attained by a function. In my item sorter, the range is just the set of colors which are currently occupied. I've only used the red, orange, and yellow chests, so even though there are green, blue, and purple chests available, I haven't used them, so they're not in my range. When we're talking about a function, it's often useful to give it a name and to show what the domain and the codomain are. So let's call our item sorter Bob. The notation here is to write the function name followed by a colon, and then our domain with an arrow pointing to the codomain. For our item sorter, this reads function Bob from the set of items I've collected to the set of chest colors. If we want to represent the idea of applying a function to some element of the domain, we write the name of the function, followed by the desired element in parentheses. So if we want to apply Bob to Oakwood, we write Bob of Oakwood. The corresponding color is red, so we write that Bob of Oakwood equals red. Okay, great. Bob is going to serve us pretty well, I think. Right now, Bob is configured so that each chest only holds one kind of item. The red chest only holds oak wood, the orange chest only holds dirt, and the yellow chest only holds cobblestone. That makes it super easy for me to find the oak wood because I know that if I go to the red chest, I will find oak wood and only oak wood. This is the idea of an injection. Injections have the property that any given element from the codomain can be matched with at most one element from the domain. Bob is an injection because red is only matched with oak wood, and orange is only matched with dirt, and yellow is only matched with cobblestone. The other colors aren't matched with anything, but that doesn't matter because we only require that each of the colors is matched with at most one item. Alright, I've gone out and I've collected a few more things, so I've gotten some iron, some coal, some gravel, and some oak planks. So I've modified Bob to put the iron in the green chest, the coal in the blue chest, and gravel in the purple chest. But I've run out of chests, so I've decided I'll put the oak planks with the oak wood over in the red chest, because I figured that they're close enough that it shouldn't be much of a hassle for them to co-occupy the red chest. Bob is still a function since each item is always sent to the same chest as other items of the same kind. Like, oak wood is always sent to the red chest, and iron is always sent to the green chest. But now Bob is no longer injective, since the red chest is being shared by oak wood and oak planks. However, Bob is now a surjection. A surjection is a function with the property that every element of the codomain is matched with at least one element from the domain. Pay attention to the range, because with a surjection, the range contains all of the elements of the codomain. And if we look at Bob, we notice that every possible chest color is now occupied, so we've matched every chest color with one or more items, and so Bob is surjective. I've done some additional mining, and I decided, you know what, I'm going to expand our storage shed a bit. I like having one item per chest, because it makes things so much easier. I've added the remaining 10 colors Minecraft has provided, so I moved the oak planks from the red chest into the black chest. But I gathered some sticks, torches, cooked chicken, saplings, seeds, apples, gold, redstone, and, thankfully, some diamonds. I've modified Bob to take these new items into account, and so now we have one chest for every item, and one item in every chest. Since there's only one item in each chest, Bob is injective, and because we've used up all the available chest colors, Bob is surjective. With these two properties, we say that Bob is bijective. Any function with both of these properties, injectivity and surjectivity, is said to be a bijection. In other words, bijective just means that I can perfectly pair off the elements of the domain with the elements of the codomain. Thank you, Bob. You've been most helpful. Next time, I think we'll introduce some capability to return items from a particular colored chest. I really don't feel like walking all the way to the end of my shed every time I want some redstone. But until then, I'm gonna go mine some more.